Good morning, good afternoon, good evening, depending on where you are. Welcome to this webinar on massively accelerating PSCAD models, including manufacturer real code controllers with HYPERSIM. I'm Etienne Leduc. I'm Energy Market Offering Manager at OPAL-RT, and I'll be the host and the presenter for today's webinar. So we'll start with a little background on the feature, also give you an overview of the component that we support so far. Then we'll look at the entire workflow from importing network, importing entire plants, importing then the manufacturer real code DLL import, and also accelerating heavily the simulation thanks to multi-rate, multi-target co-simulation. Then I'll give you a quick look at other things that we have besides our hybrid co-simulation, PSCAD with HYPERSIM. Then talk about the PSCAD model analyzer that we have to help you analyze your models. And we'll finish with about 10-15 minutes of Q&A. You can start sending your questions at any time during the webinar using the questions section, the questions widget in the GoToWebinar dashboard, but we'll answer them at the end in the Q&A session. So just a bit of background, it's not the first webinar that we have that talks about the project we're doing with the Australian energy market operator. But I still like to remind the size of the network that we are working on to import from PSCAD to HYPERSIM. So it's a 4,000 buses network. It's really huge, covering the entire east part of the Australian network with over 150 inverter-based energy systems, with over 300 pre-compiled DLLs that are the manufacturer real code that is integrated into the simulations. It's really a large network that's been pushing the development of this feature and is actually a very great benchmark for us to develop and validate the functionality. So we achieved so far a computation time that's about 58 seconds for 20 seconds of simulation with 500 cores for this 4,000 bus grid. We're still looking at improving this time. We're using here one high performance computer with 128 cores at 3.35 gigahertz maximum clock speed. And we have 22 high performance IPCs, 80 core each for a total of 396 cores at 4.8 gigahertz to maximize performance for the DLL computation. None the least, we have 128 gigabyte per second throughput and 138 nanosecond cut-through latency. Those numbers are very important also for the global efficiency of the entire system as we have co-simulation between several targets. So results, we just improved the performance. Some of you had attended other webinars we did in the past year. Last time we were achieving 3.6 times slower than real time. Now we're down to 2.9 times slower than real time, and we're still looking at improvements in the future. So this brings really a 20-second simulation down to a 58 second. So it's quite the achievement in comparison to several hours for the same simulation directly in PSCAD. In terms of support overview, now we support, or we'll actually support in about a month. We'll finish this first big phase of 48 power components. We're talking about PV, machines, sources, and more. Different kinds of transformers, line cables, switches, breakers, RLC loads, arresters, and more. So it's quite a lot of power components that are supported and validated in several different use cases. We also support 138 control functions, more dedicated PSCAD functions, measurements, signal connections, and widget. So it's also quite broad for all the control systems. We've presented in the past this benchmark for IEEE 39 bus network import back at RT21 last year. So this is being migrated automatically using import tool through the OPAL-RT unified database. That is our centralized database and single source of truth. And once in HYPERSIM, we can achieve a performance of real time on one core with a TS of 17 microseconds. So it's quite much faster than what you could do with PSCAD. You could see a full demonstration here in this link. that I publish, where you'll also see the actual results of this simulation that very accurately match between PSCAD and HYPERSIM under a three-phase fault. Today I have a new benchmark that I can show with the IEEE 118 bus network. So I have a short video to show you again the workflow and how it looks like once in HYPERSIM. So you can see here, most of you must already know this benchmark here that you can find in a PSCAD website. And we have this import menu here. Go and select the PSCX file from PSCAD. Then we have the entire import. We're actually positioning all the components at their right location based on the data that we have from PSCAD. We still support then importing all the parameter values that are set in all the components. We're wiring everything together. So it's pretty much ready for load flow validation and simulation start. And we also provide, beside that, a tool or an analysis report that is automatically generated with the import tool to let you know what's the status of the import. Are there any missing parts? So you'll see there's a bunch of different reports here that are available. We'll just look just at one here for the moment, or you'll be seeing whatever has not been mapped. In this case, everything was automatically imported. Nothing was left behind. But you would normally see here if there were anything left behind that had not been mapped, you'd have a detailed list so you can actually easily manually cover whatever is missing after the import. The next part after you've imported your main grid is dealing with the different plants. At the moment, it's better done separately from the main grid, although in the future we'll be looking at the really almost a one-click button to import the entire grid with every steps that we're looking into the webinar today. But at the moment, it's done separately. It's better done this way and faster. So I have here a typical plant, a wind turbine plant, or you have a different manufacturer DLLs for the different levels of control that you have for this wind turbine plant. These DLLs are typically a Fortran code generated with PSCAD in 32-bit for 32-bit operating system. And you'll see then once imported in HYPERSIM, we can import really a large part of the plant model using native HYPERSIM components. And for the DLLs at the moment, we'll add kind of dummy components that are used to prepare the DLL integration that will be readily connected to all the different signals in the power system. And we'll see after the next step, once you have your DLL ready, you simply need then to delete this block, replace it with the real DLL block, and then you're good to go for simulation. So it's really to facilitate the import and interconnection with the DLL from the real code from manufacturers. So how do we do this? Well, we're generating automatically a wrapper DLL that's based on the Segrè workgroup B4-82. That is along with the unitary test to validate it against PSCAD. So we have a wrapper that goes around the manufacturer real code DLL that's in Fortran code. And this wrapper DLL integrates the Orchestra publish and subscribe communication interface that we've developed and handed to HYPERSIM to facilitate the co-simulation that we're doing to accelerate the PSCAD simulation. And so this wrapper DLL allows the communication between all the different DLLs in the HYPERSIM engine. So you'll see, as I said, for now, there's a manual intervention required at this point to finalize the wrapper DLL connection to the plant model and make system validation tests. But before then, we're actually automatically importing the DLL along with unitary tests to make unitary validation. And then the only things that remains is to integrate that into the plant model and validate it together with the DLL. Some principles on the Orchestra system. So it's really an application level data communication layer that is leveraged both in HYPERSIM and RTLab framework. So we're really focusing on HYPERSIM, but it's also available in RTLab. It's a publish-subscribe based mechanism. It's domain-based strategy to logically separate the different simulated system. It's data-centric for ease of integration and interoperability. There's also a very low latency communication system, as I was mentioning in the earlier slides. This is very important to achieve a good performance. We can handle synchronous and asynchronous modes, so a multi-rate simulation with iteration, interpolation, and compensation wherever it's needed. And we can deal with dynamic connection, disconnection of components during the simulation. So here's an example of a plant that I can't mention. Those are the results that you can see between PSCAD and HYPERSIM. They very accurately match. This is the instantaneous voltage and current measurement that you would find at the point of common coupling. So we have very accurate results for an entire plant model with the controller code from manufacturers. About real-time simulation, just a few words with manufacturer real code. So it's feasible under certain conditions, but typically when those DLLs are really not particularly ideal for real-time applications. Instead, would prefer dynamic or static libraries that are directly compiled for Linux operating system that is much more controllable to achieve real-time performance. It really then varies on the type of DLL that you're going to have, how much room you'd have for a jitter depending on the OS. But for best performance, would always prefer to have a Linux operating system. So for that, we can provide the Linux virtual machine with which customers can actually recompile the controller code for Linux operating system and create new dynamic static libraries for real-time application. It's really not a complex process. It's something that's been done several times already, and it's really best for performance. For users who don't have access to the source code, well, collaboration from manufacturer is necessary. And from our experience, several of them are open to it. They've done it already. We have several use cases, for example, where manufacturers have been collaborating with utilities or even universities to help with generating this code for Linux operating system. So it's really something that you can discuss with them. And in the end, if it's not possible to compile the code for Linux, there are still more complex approaches that are possible. Some constraints, limitation will apply. And then I would encourage you to contact us to better dig into this topic together. So on a larger perspective, we're really looking at multi-domain, multi-rate co-simulation. This is really the vision behind the Orchestra co-simulation framework. We're focusing today on the DLLs from manufacturer, but the goal is really to help having the integration of thermal models, oil and gas networks, communication network, FMUs, power electronics, power system, and so on, all into the same simulation with a co-simulation network that has a minimum latency and best performance to make sure that we can have the most possible detailed simulation that includes all of the different assets in the power system to get the best accurate simulation. So this is really the vision that we have, that we're working on, and we already have quite a few of these bubbles that are already supported, and we'll keep working on the ones that are missing. So what this can help now is that we can have then the plant models and the entire grid actually run on a PC that is more optimized for this type of simulation. We have the expertise to select which kind of CPU will be best used for these kind of simulations. And separately, we can optimize also the different PCs that we use for DLL simulation because they have different constraints. And to have the best simulation performance possible, it's better to select different PCs for the different parts of the applications. And this is something that the Orchestra co-simulation framework enables with this fast 5 gigabit per second communication link. So we've developed also a high-level tool to give you an overview of this multi-target co-simulation. So you can actually see here, we'd have all the IPCs that we had in the project here. You'd have a detailed list of all the simulations that are running, all the processing slots that are being used on each PC. So you can really have a detailed overview of how the system is used. We've also added the maintenance mode, so you can easily handle some maintenance work of upgrading software and so on. and make sure that the entire system is still operable and users can connect and add simulation without actually regarding on which PC they will load the simulation. This is all handled automatically. So you can actually get an overview of your system here. And on the second pane, you'll see also who's the list of users, who's the list of PCs, when their simulation started, when it ended, or when it's aimed to be ended. So you can also manage multi-user simulation on the platform. And we're looking also in the near future to add some kind of serialized pipeline system to optimize the simulation performance with multiple users to help with a large number of simulations on the large system. Then a few words on something that we've also been looking at throughout this project is hybrid PSCAD and HYPERSIM co-simulation. When we're looking at migrating a very large grid like the one we have with AEMO from PSCAD to HYPERSIM, the validation process is better done iteratively. So we made this hybrid PSCAD HYPERSIM co-simulation possible. So this means that we interface an entire PSCAD plant, so both the power system and the controls, with the HYPERSIM power system. We use lines or transformers to decouple the network. And thanks to the Orchestra co-simulation framework, it can be used to perform the simulation, the communication between the two tools. And this is really best for validation capability, because we can gain quick validation capability requiring only a few changes to the PSCAD model at the expense of some global simulation performance. Obviously, will go as slow as the simulation in PSCAD, but still, as the plants can be separated, instead of having one big grid with all the plants into the same grid running on a very low number of processors, because PSCAD has really limitations in terms of parallelization, you can still achieve great performance gains with having part of the grid already simulated in HYPERSIM and being parallelized on all the available cores that are in the machine, and having all the plants that have already been migrated to HYPERSIM then be parallelized with all the DLLs running on the dedicated PCs and the dedicated processors. You gain all of this performance, and then you can still gain performance by having the different PSCAD plants that have not yet been imported to HYPERSIM being split over several CPUs. So not always in the same process as you would have in PSCAD, but the plant themselves can be parallelized. The plant entirely will be one single big task with its DLL, so it's still slower than when it's going to be in HYPERSIM, but it's much faster than having all the plants in the grid together in a one single PSCAD simulation. So this really helps in the migration process to give validation capability that will be much faster than running the simulation in PSCAD. So you can see here in this diagram how we would achieve this. And so you'd have like the typical HYPERSIM grid that's been migrated already. You have some plant models that have been migrated already, as I have described in the previous slides, where the DLLs are run on dedicated processors to maximize the performance. But we could still have the PSCAD engine run with an entire plant decoupled through a half line, communicate with the HYPERSIM model for a hybrid co-simulation. You can see here, again, I can't mention the plant that's been done with, but those are really accurate results between PSCAD and HYPERSIM. So we really get very good results. You can see here the actual error level that's below 0.04 PU, and for the different types of faults that we've applied. So it's really low error margin in this co-simulation approach. Last but not least, to really help you with analyzing how much work it's going to be to migrate your model from PSCAD to HYPERSIM, we've developed a little tool, an executable that we can share with you, that you can run on your within the folder of your project, that can analyze the PSCAD models that you have and we'll provide a report that in two parts, one that is less detailed that you can easily share with us, and one is more detailed that eventually you might see depending on your constraint, if you wouldn't sign an NDA or anything before sharing this report, or we can actually at least discuss on the content of the report if you don't want to share it. I'll just go back here. So this is the first report that you'll get that's very helpful to us, that gives us the count and the types of the different components that you have from PSCAD, so we can easily analyze compared to our list of supported components how much is already supported. So in cases like the IEEE 39 bus system or the IEEE 118 bus system, we already support 100% of them. But we never know when the different networks that you're dealing with, maybe there are some components that are not yet supported. And this list is really going to help us analyze that and give you a good idea of how much work is left that would either need to be done manually or that we will support in the context of your project. And moving just a bit further to a more detailed report, we can actually get the full detailed list of all the components, their parameter values, and so on. So we can see also additional constraints, limitations that PSCAD may have that we need to consider. There are a lot of things that we've done already, like managing links under the hood between different components in PSCAD. Those are the kind of things that we've done, but we never know. There might be some things here that we realize are missing. So this report can also be even more helpful to define how much work would be required for the migration of the model. So it's something that you can either share directly or we can sign an NDA when necessary to get this model to give you a really better overview of the amount of work that would be required to migrate your model to HYPERSIM. So in conclusion, we will support by next month close to 200 components. Upon import, we can take care of GPS coordinates if they're available, else we have optimal placement of the components. All components are connected, their parameters are all set. It does, I would say, in average, 80% of the job already depends on the model. As you've seen with the IEEE 39 bus and 118 bus system, it's almost 100% of the work. There would still be some cleaning up if you prefer to rewire some part to make it look cleaner. Obviously, there's some work to be done here, but I would say in average, it's at least 80% of the work that will be done automatically. So it's a huge time saver instead of building the network from scratch, obviously. And the larger the network is, the more time you'll save using this tool. It can really accelerate simulation by several hundred times. I would say in general, it would achieve real time or even faster. Although some conditions may apply when you have DLLs in the loop. But we've even seen, even with the network as large as achieve very close to real time. We're still aiming eventually at achieving real time for this network. So this is really a huge gain of performance in comparison to hours of simulation with PSCAD. We can definitely help you analyze your models and accompany you throughout the migration process. And in the future, we'd aim at a single source of truth database, allowing you to switch back and forth between PSCAD and HYPERSIM really seamlessly. So thank you very much for your attention. I would be really glad to answer any questions you may have.
There is some question, Etienne.
Yeah.
Salut. Hello.
Thank you, Pierre.
Just to confirm with the question from Wendy, 0.1 PU error is 10%. Is it considered as good, very good, average?
It really depends on the use case. It can be defined with the customer depending on the use cases. In most cases, we considered less than 5% error between the two tools. And I mean, this is a topic in itself that could require a webinar, but having a difference between PSCAD and HYPERSIM also needs to be analyzed. I mean, both tools have been thoroughly validated against several real use cases. Sometimes it's difficult to tell which one has the real answer. So every use case needs to be analyzed separately. But having a 5% difference between the two tools already just upon the import for us is a really, really good value. That does not mean that the error cannot be reduced with further tuning of the model once in HYPERSIM. It's something that can definitely be done. And this needs to be really analyzed on a case-by-case basis.
Thank you. Next question from Andre. Could further time improvement, could we expect time improvement with 64-bit native libraries, DLL, and
if I understand the question well, I mean, once we bring the DLLs to the Linux operating system, in this case, ideally would be 64-bit. Yes, there are a lot of potential of performance improvement, especially when you look at the OS performance, as Linux is way better in terms of what we can control to minimize the jitter. But there are also considerations just in terms of how the DLL is coded. I mean, with some manufacturers, because of the fact that it was running offline simulations, there was not always considerations for the raw performance of the DLL. So we do see DLLs that by default are slower than their execution time step. That could require optimization from the manufacturer. Or from yourself if you're the manufacturer. That's something that we can also help with our expertise on real-time simulation. So it really depends on a case-by-case basis, but typically, yes, when you go to Linux, to 64-bit system and to the latest compilers, you'd achieve better performance in general for the simulation. Obviously, the DLLs also apply to that if you can recompile them for Linux with the most recent compilers. And have access to the source code to optimize the code for real-time simulation, you can actually achieve big gains. I mean, something that I mean, it's our core business, the real-time simulation. There's no model that cannot be brought to real-time. It's really a matter of expertise in the coding for some of the DLLs. But I must say, in general, for most of the DLLs, they typically are faster than their actual time step. So we could bring them to real time on a Linux platform. I hope this answers the question.
Thanks. Another question from Andre. Is there, I'm not sure I understand the question, but I'll ask you, is there any compatibility chart for HYPERSIM detailing which Fortran version or Visual Studio GCC version are supported?
For Fortran, I mean, this is really the PSCAD part. Once the DLL is coded, it doesn't really matter which version will have been used, as we have developed a tool to import the DLL and have a wrapper DLL around it that's going to call its function and map them to our orchestra system. So that part doesn't really matter. For HYPERSIM, we don't use Fortran code. It's typically C code that we will use for real-time simulation. And I mean, there's several Visual Studio versions that can be used. This does not really matter to develop your code. If you have some specific question on some specific versions you'd like to get better insight on, just please contact us and we can have some technical people look at it with you.
Okay, thank you. Question from Arun Prasant. DLL can only be run on Windows, right? In Linux, we have .so files. How can you migrate DLL to Linux?
In the context here, what we did is the co-simulation with Orchestra. I believe I did not mention it, but on the different PCs that are optimized for DLL, it's Windows that is running. Windows itself is, as I said, I can go back a couple of slides on the real-time simulation. So Windows itself can, in some conditions or for some contexts, be used for real-time simulation. For anything that is, I would say, less, I don't want to say not critical application, but are less, have less constraints on the timing. Say with slower communication protocols such as C37118, it's something that we've done already. You can actually run quasi real-time simulation on Windows with communication protocols, and the performance is mostly good enough for several applications. It really depends on the level of performance that you're looking for your application. But in general, Windows is really not optimized for real-time performance. The jitter is higher. We have less control over it. And so that's why I said you need to have access to the source code to recompile it from Linux. A DLL, yes, as you understood, is meant for Windows. It's not meant for Linux. So we need to have a recompilation of the code. And this is why we provide a virtual machine to our customers so they can easily, and with the documentation accompanying it. As I said, it's really not a complex process to recompile the DLLs. It's something that's simple to do. Using our virtual machine, you can recompile it for a Linux operating system.
Thank you. There's a mention here. You talk about a SIGRE work group.
Yes.
Just a minute. It's for real-time. This work group is targeting real-time simulation.
And most specifically, the interoperability of the different manufacturers and tools. The goal is to simplify the interface of DLLs with any tool. So to define what kind of guidelines should be used by everyone who develops DLL to make sure that they are interoperable with the different tools. So today, this is really a challenge. This work group is quite new. Most likely, they realize that it's difficult to exchange DLLs between different tools. Here we're talking about PSCAD, but I mean DLLs. I mean we have several Word DLLs, FMUs. There's tons of different tools that will generate compile code that you'd like to integrate into your offline or real-time simulation. And at the moment, there are not really standards. I mean, FMU is definitely one, but on the DLL side, there's none. So SIGRE work group is really aiming at defining this standard to help with the interoperability of the DLLs from different manufacturers and the different simulation software tools.
Thank you. And a question from Wendy again. Good. We like question. He's wondering how we make available new model. We code the new model, and do we compare the result with the real hardware equipment, or can you talk about the process?
I am unsure I understand the question, but in our development process, I can go back. I believe I did not include that slide. I had a slide, I think I did not have time to present it, but I had a slide showing, for example, the process of supporting a transformer model. So you'd really see just having the transformer in PSCAD, going to HYPERSIM, all the unitary tests that will be done on the different use cases, applying different types of faults or different scenarios to make sure that both models behave the same way in the two tools. So it's really the kind of work that we're doing. This is also why it takes a lot of time. It needs, first and foremost, it needs a lot of validation for each component individually before we start thinking about importing entire networks. Otherwise, once we get to a model like the IEEE 39 bus system, or even bigger than that, it would be a big challenge to make validation between the two if there were big discrepancies. So at first, what we need to do is really run thorough validation on each and every of the components in the network to make sure that they behave the same way in both tools and as many use cases as possible. So once we get to the full power system, we're very close to having exact simulation results, as you could see in this slide here. So I don't know if that answers the question.
So you compare the model, the result in PSCAD for a unitary model compared to the same unitary model in HYPERSIM.
Exactly,
so,
and
okay.
And for a lot of different use cases. And I mean, some models they're not exactly the same in PSCAD and HYPERSIM. I mean, historically they have not been coded the same way, or sometimes they don't necessarily use the same equations when we look at machines or more complex models. So this is the most challenging part. I mean, simulation is always, it's mathematical equations. It's not real life. It's always at least partly not exact compared to the real power system. And the question is more how close can you be to the exact behavior? And both tools have been developed and thoroughly validated against several real use cases. So typically, both tools use very good equations, but that does not mean that they may not match exactly depending on the different components that you're looking. So there's quite thorough work to do for us to make sure that we get as close as possible to the results that we would get in PSCAD. When it's not exactly the same, explain why it's different, validate against real cases what would be the closest. And I mean, we have a lot of different solvers to base our analysis on. The HYPERSIM is not the only solver we have access to. We also use different offline tools to validate the results that we have. When we get different results between PSCAD and HYPERSIM, this triggers a thorough investigation on our part. So this is really why this project is taking so long, is to make sure that in the end we provide a very robust tool to migrate your model from PSCAD to HYPERSIM, so you can feel confident in the simulation that you're going to get out of it.
Thanks. Just a clarification. When you say real use case, are you referring to field measurement?
Exactly.
Yes. Okay. Thank you. Question from MD Abu. Is there substation automation included in HYPERSIM? I mean, synchrophaser communication possible without testbed and physical PMU. So can we simulate PMU?
Yes, we have a PMU model that's very thorough and is matching the IEC or IEEE standard. I don't remember which one, and that is available. We even have a demonstration model that you can see if you go on our wiki. You can see in the demonstration section we have this documented. So this is a little beside the point here. It's not related to PSCAD, but yes, we can. We really have a detailed PMU model. We support C37118. You can have virtual PMUs all around your model. I don't remember in the full list of model if we can actually match the PSCAD PMU model so far. Something I would need to check if that was the aim of the question. But we do have a detailed PMU model in HYPERSIM.
Thanks. Just a remark from, I'm not sure I will pronounce the name, Joa. Sorry about your first name. A video demonstration, would it be available to show the import function?
Yes, well, this entire webinar will be uploaded on our website after the event. Email will be sent to all attendees to get the link to this video. So
no, I mean the video of the live import.
Yes, well, as I've shown it for the IEEE 18 bus system, this is also part of the webinar. If you want something more, just contact us. We can see how to best address your question.
Good. Question from Wendy. Did you validate the AIMO with network so far?
We are in the process of migrating the model. I can't say how far we are so far, but big regions were done with several plants. Thorough validation has been done already. There's still a lot of work to do. It's a very, very big network, but it's underway.
Okay, thank you. A long question from Arun Prasant. What I find out when working with source code associated with DLL is that they use a lot of Windows-based C and Visual Studio libraries. So how do we find the library support for those functions in Linux?
I am unsure. I can't answer this question, but we'll take it after the webinar.
We'll get back to you. We'll get back to you. I think you did. Congratulations. Merci. I don't have any more questions so far.
Thank you very much, Pierre. So, well, thank you to everyone, to all attendees for your time. If you want to stay in touch and learn more, there are still a lot of webinars coming up. If you go on www.opal-rt.com/learning-journey, you can see the list of webinars that we have running still for about 3 weeks. If you want to learn more about our solution, just dial on our website. And thank you again for your time, and have a good rest of the day. Goodbye.
Thank you very much. Thank you, Etienne. Thank you, everyone.